In a recurring decimal question, it's important to see how many digits the recurrence occurs over. So in this case, it's just the 2 that repeats endlessly. So if effectively it's repeating every 1 digit, that would be opposed to 0.32 with a dot over the 3 as well, which would be repeating over every 2 digits. Now, if it's repeating over every 1 digit, we call our fraction x and we multiply it by 10. If it were repeating over 2, we would multiply it by 100 because what we do when we multiply is we get all the repetitions to line up. And what that means is that when we subtract our initial value from 10 lots of that value, we actually end up with 9 lots of that value, and all the endlessly repeating bits cancel out by the subtraction. So that cancels that, and we're left with 9x being equal to 2.9. If it was 0.32 recurring, we'd multiply it by 100, and then we'd have 99x equals whatever it equals. But we'll ignore that for now. So 9x equals 2.9. We need to turn this into a fraction. Well, you can't have a decimal in a fraction, so the first thing we can do to get rid of that decimal is to multiply both sides by 10. If 9x is 2.9, then it follows that 90x equals 29. And if 90x is a 29, then x is 29/90. One thing you need to be careful of is whether or not this fraction cancels. You'll notice that this question is worth 2 marks, which suggests that it doesn't cancel. If it were worth 3 marks, it'd either be a more difficult recurring decimal, or you'd probably have to spot that it cancels. 29 and 90 have no common factors, so 29 over 90 is the final answer. Make sure you show working for these questions. Lots of calculators now are very clever, and if you type in 0.322222, it'll come up with the answer for you as 29 over 90. If you just write the answer, you get no marks in this question.